This is Ruby metaprogramming, how to do it wrong. So we'll just jump right into it. How many Ruby people do we have in here? All right, a little bit, perfect, cool. And of those people, how many of you know metaprogramming or have used metaprogramming or are familiar with? All right, cool. So we have.
We're both bad people.
Yeah. So we're going to go over Ruby kind of in a general sense and kind of explain what metaprogramming is and what it does. We're going to look at how metaprogramming gets developers into trouble and even us into trouble. The 3 deadly sins of metaprogramming, basically what we see most often in the assessments that we're doing, and how they manifest themselves in vulnerabilities. And then we'll try to go over some examples of good metaprogramming or kind of some general rules and how to mitigate some of these things. So the first thing is, what is Ruby? If you're not familiar, and those that are not or didn't raise their hand, it's a dynamic open source language with a focus on simplicity and productivity. That's directly from their kind of mantra. You can see the greeter class here is just a really simple way to say hello to the world. We're all familiar with that concept. And what is best in Ruby? Well, it's elegant, it's simple. You're not bound by a lot of the things you would have in some of the larger frameworks and languages. It's easy to deploy, it's productive. There's gems for pretty much everything you want to do. So if you don't feel like writing something, you could probably get a gem that's readily available. But it's also very easy to shoot yourself in the foot with. All the same things that make Ruby so great can also really cause some intense problems. And what is metaprogramming? Metaprogramming is commonly defined as code that writes code. That's kind of a definition, but really it's code that manipulates language constructs at runtime, so it's kind of that specific. And I think that Mike can talk more on this example from Active Record.
Yeah, so metaprogramming is a very powerful kind of part of Ruby. Basically, it's an idea where you're writing code at runtime, so you can think of it as like method definitions that don't exist until they're created at runtime, which a lot of languages can't support. And so you can do very interesting things, like this is an example from Rails where if you've ever used Rails before, there's very powerful find by, they're called dynamic filters, but it's basically find by any attribute or column name. And none of these methods are actually defined. What Ruby does is it uses this technique called ghost methods, which at the top of the screen you might be able to see there's this method defined called method missing, and of the Ruby call stack of methods, that's called last when it can't find any other method with that name. And what you can do in Ruby is overwrite that method. Since everything in Ruby is open, you can rewrite classes, you can rewrite pretty much everything. You can rewrite that method, and then it'll run some dynamic code for you. So what the Rails guys did was they created this method that when you say find by name, for instance, on the user class, and you pass in a name, there's no method that's being called that's called find by name. There's no def find by name. What gets called is method missing, and then it calls down to this run find by method, and it does some kind of basic string operations, and then it finally just packages the information that you want up into a where call down there at the bottom. But instead of having 100 find by name, find by date, find by whatever columns you have in your database, you have this way to write way less code and still get the same effect. So that's where metaprogramming's insanely useful, is that you can write way less code and still have the same powerful code available to you.
So now we're going to get into the 3 deadly metaprogramming sins. These are probably some of the most misused methods that we see, or I guess you could say metaprogramming techniques. And we're going to go through, we're going to show you what each one does. We'll talk about how it's used poorly, where it is used, and how we've seen it used in our assessments. The examples we'll go over are actual code snippets, kind of cleansed and whatever, but they have been used. They're in real applications. So before you say that's got to be a goat, whatever, it's in there. So the first one is send. Send is pretty simple. It invokes the method identified by the symbol you're passing any arguments that you specify. and it's pretty much equivalent to what you would see in a dot notation. So you call dot length, you call dot sum on something or something like that. It's the same thing as passing send with any arguments that are relevant to that. So you might say, well, why would I use that? Why wouldn't I just use dot notation? One thing is that dot send is faster, so if it's a benchmarking issue, you could use dot send for that. You can dynamically decide what method to call at runtime, like we've been saying. So if you don't know what method you're going to call, and we'll see an example here, it'll allow you to call that method based on input or the context of the application or whatever it might be. Now on the back end, you can call private methods, which there's a big argument about that. There was a change in Ruby that kind of reverted that idea, saying, okay, we're not going to call private methods, but it was ultimately reverted, and now you can still call private methods if you're looking to do that in some kind of interesting way. But most importantly, like I said, you can decide what you want to call at runtime, and we'll look at this example here. We've defined a method in the controller, and basically what this does is the one there, the find one, is kind of mimicking a user session, right? It's passing in a parameter type. In this case, it's an attribute. So it sets a variable to the parameter passed in by the user, and then it's sending that method, or in this case, the type of attribute, directly to the employee with a value. So if the user passes the name type, then it's sending the name that they want to change to. And then it's going to save that user and redirect back to the path. So what are we really achieving here? We can use this particular method for multiple types, right? No matter how many types we add to this user object, we can just have this 5 lines of code continually do that same function. And it'll allow you to add dynamic actions if you want to do that as well. But there are some issues with it. But let's look at how it works.
Yeah, otherwise you'd have to have, set username, set name, set date, set whatever. Anything you have in your model or your database, you have to have an individual method to set.
So this is a pretty rudimentary example, but it's an edit profile page, and most of the examples in this application. This code will be available after the talk if you want to mess around with it. But you essentially will select a attribute for the user, and I can rename myself to Bob, for example. And you'll see my name here changes to Bob. And I can also edit my status, and I can say, okay, I'm unavailable now. Okay, so I'm unavailable. But because you are allowing the user to enter whatever they want, some parameter tampering here will allow me to kind of pick the status and say, oh, I want to make this much money. And if I send that and intercept the request and simply change this type to, I'm guessing, salary, since everything seems to be pretty straightforward there, I should now have a new salary, right? And that's kind of the problem with send in a nutshell, is that if you're not taking some steps to mitigate that, then you can have an issue. So what do we see? Obviously, it allows the user or the attacker to determine what method is called, and you're really trusting the user to use your form and use your input. And it allows an attacker to take advantage of this and use methods that the developer may not have intended. Also, we have a common use here. Did you want to talk about that?
Yeah, so in this example, this is a way to shorthand, kind of create a configuration for, in this case, it's keys for different social networks. And so it's kind of a common way you'd use send in a good way, not in a bad way, but in a good way to basically create a configuration for like Twitter or Facebook, where instead of saying OAuth key equals this, secret token equals this, callback URL equals this, you're basically just looping through all these things and using send to set them. So this is kind of an interesting way of how you use send and why it's useful. So it's not all bad.
So going back to the methods that you could call, I just did a grep on basically all the methods that end in that equals. You saw that I had type equals, right, for the parameter. This is everything that you could possibly call what that ends in an equals in a method, right, of that particular object. So you can see I have my employee object, and I can send any of these as a user. So some of these are, destroy callbacks, record timestamps, and I could maybe mess with these in interesting ways. But you are exposing all of these methods to your end user when you're calling send and not doing something to fix it. So how do we fix it? The general rules are try to avoid using user controllable parameters with send when you can. If you do have to, you want to try to whitelist those parameters in some way. And we have an example of that. And then wherever possible, if you don't need to use send, don't use it, just use the standard dot notation. Obviously that wouldn't be metaprogramming, but this would be the fix that we've implemented in some way. Maybe not a production level fix, but a fix nonetheless. So we've defined an acceptable parameters array. That way we do the if check on the type. So when the type comes in, it's saying, it's setting the type with the parameters, but if it's not equal to one of the two that we've defined in the array, then it won't do anything and just redirect back to the path. And we can kind of show that fix. Here. And let's just hope for the best with the demo, right? So if I take my status, and again, I try to change my salary, and intercepting that request. Shouldn't do anything with that fix applied because it's not in that array. So my salary actually hasn't changed. I'm still making big bucks, right? So that is send. Next, Mike's going to talk about constantize.
And that example was actually straight out of a Rails assessment we did. So that is a legitimate example we've seen. And that's also the fix they used to get around that issue. So, so constantize, this is a really interesting Ruby-ism, but it's a way to basically, at runtime, create a constant by looking up all the constants that are defined and basically creating an object with that, whatever you pass in, creating a constant with it. So what you can do with that is, you can see in this code, we're taking a parameter, params class, and then we're running constantize on it. And then the goal here, the original goal of what the Rails developer was trying to do is take in multiple different database tables, so active record objects, and run a find by ID on them. So this way you don't have to say like user find by ID, classes find by ID, cars, whatever whatever kind of application you're running, and you have different models. This way you can just dynamically define, I'm going to take a class from a user, and I'm going to take an ID from a user, and then I'm going to search that table for that ID. So if anyone can't figure out why that's a bad idea, we'll show you. But this is a pretty common issue we see in constantize. One of the first things we do when we look at Rails apps or Ruby apps in general is searching for just .constantize, and you'll always find examples of this. So why would you use it? Again, it's great for reducing repetitive code. You don't have to have a user.find by whatever, a class.find by. It's just one method to do all that for you. I mean, Ruby is very big on the whole dry, do not repeat yourself, or don't repeat yourself. So they're big on reducing the amount of code you write and just reusing code over and over again, which is great. It makes it, it makes applications smaller, it makes code more easy to read. But you can shoot yourself in the foot with some of these techniques. So, so yeah, again, it achieves this functionality with less lines of code. There aren't 20 different method definitions to do the same thing, so it just makes things a lot more simple. But it allows the user or attacker to run this function on any class. So pretty much any class that's defined that has find by ID defined on it I can now run that. That might not be an issue for a lot of things, but when it comes to active record classes and models, that's where it becomes a big issue because I'm basically able to dump out your DB. So here's another example of constantize. It's a little more involved than the previous one, but here we're taking two parameters again. Payment method is what becomes the class. the payment method type becomes the class, and then we're passing in parameters to it. And then down here, we basically save that model. Right here is an active record model, which maps to a database table. We've now passed in the database table name and the database table the database information we want to update, and we just ran save. So whatever we just wanted to update in that database, doesn't matter what it is, we can now do it with this code. So awesome for simplicity, usability, reducing code, terrible for security. So, and we'll show that example. Oops, natural scrollers. So,
just go to the root.
Demo fail. And this code, all this code is available online. We'll show you the link at the end. So here we have basically enter an employee ID to validate. So enter just a random ID. What do we get back? We have the name of the employee, we have the email. And then down here we're kind of showing, this is some backend information you would normally see, but this is the actual, the class that is defined. So we can see it's an employee class, which maps to an active record model. So pretty straightforward. So now if we hit submit and we intercept, and we can see we had these two post parameters. One is class equals employee, and the other one's the ID. So what if we change employee to client? Because we think that's another active record model / database table in the application. Hit forward, drop the intercept, and what do we have back? So now we have, instead of an employee profile, we now have the name of the company, an email, and you can see down here, here's the actual Ruby class that we just pulled back. So you can kind of see how with this issue, you can pull back anything in the database pretty easy. So all you'd have to do is you could use something like burp intruder, iterate through all the database table names, all the classes you think that are defined in there, and then just start iterating through IDs, and you've just dumped an entire database without SQL injection. So just using the normal functionality of an application. So how do you fix this? It's pretty similar to the previous fix. You want to have a whitelist of the classes that you want to allow be enumerated. So if you want employees or info, some database tables, active record models to be searchable in this manner, you'd whitelist them. And then before you actually ran these searches, you would make sure they're included in this whitelist. And that's what we're doing down here. We have valid classes equals just employees right now. And then you just do an include, which checks to see if the class that the user passed in is in that whitelist. If it's not, then it just defaults to employee, and then it does the whole search, and you're good to go. It's a little more work for the developer because they have to maintain a whitelist, but not that much more work. So, do you want to switch it over to the right class?
Yeah.
You can demo it. So we have all the fixes up on this GitHub project under fixes.
Yeah, they're just separate branches right now. It's, so if you do end up pulling this down, you can just switch between weak and fixes and kind of see the differences in the code. So for the constant-ized demonstration, what we've done is just what he was saying. You have a valid class being employee. If the parameter is passed in, then we're setting that equal to a validation. If the array includes that particular validation, then it just returns the validation. Otherwise, it changes validation to employee and then runs through it. So theoretically, you should always get an employee object no matter what is passed. If you had multiple objects in that array, then you could use a default that that everyone's going to want to pull back to. So it might be employee, or you could return an error, kind of whatever is your preference. So if we turn intercept on and hope for the best, then we will, if we type client in like we saw before, then we should actually get the employee object, and you can see that here. So we didn't actually get the client in that case. So
now that your minds have been blown, we'll continue. I know you guys are silent because it's amazing. I know.
Yeah.
It's all right.
It's that aura. The next thing is eval. This is probably the most serious, obviously, because it is evaluating the Ruby expression passed in the string. We heard a little bit about eval in the previous talk, if you guys were here for that. But all it really does is takes a string value and evaluates that as a Ruby expression. So in this very simple example, we set a string to hello, we eval the string, concatenate it with LASCON, and the output would be hello LASCON.
So let's have a question. What should you not do with eval?
Everything.
Good, I like that. Yeah.
Right.
I was just gonna say don't put user input in, but everything's pretty good too.
Yeah. So as continuing with like our theme, why use eval? To dynamically run code, right? Everybody wants to do that.
It's all fun and games. No one's ever gonna hack you.
Yeah. But one of the interesting things is, with Ruby being such a kind of easy language to learn, you have a lot of developers that are like, man, I want to learn Ruby, so they get on something like some code training site, Code Academy, whatever, blah, 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 and they have to accept code, right? They have to dynamically run that code. And that's a business case. That's a use case that we have to consider if we're doing that. So you are pulling out of the stops, but there should be some way to do that. That's not what we see in most of our assessments. This is the single most common use of eval. You take an object, a parameter, do a find, and run the ID. It looks like something like I'm just putting up an example, but this is in a ton of assessments. It's in a ton of examples. If you go into GitHub, you'll be able to find this, and we'll look at that a little bit later.
Yeah, that one right there, even though it looks like it's running .find, that's actually, it will evaluate params, I can't even read that, params model name first. So whatever that is, if that was like a system call with ls, it'll evaluate that before it does .find. So.
Right. So what is the good thing about this? Well, we've definitely achieved the same functionality we saw in our last two examples with one line of code, so that's kind of cool. And we can perform dynamic Ruby code on objects that are available at runtime, so we can pretty much do whatever we want. So you give a lot of power to the user, which in some cases might be your goal. It also allows the attacker to execute any code they want. So you have to think about that if you're going to try to fix this. So let's look at the example of eval and how we've kind of implemented it in our demo application. And then we have another demo that we're hoping works that we kind of threw together last night. And we'll see how that goes. But this basically, again, we're going through a user profile model. We have a set of user profiles. You click on a user profile, and in the route, we don't have to define this. We only define this route one time, and we are looking for the model ID in the first parameter and the ID in the second parameter, and we're pulling back an employee. So obviously I can continue to do this for employee 3, 4, or whatever. But I don't even have to jump into burp for this. I can actually just come in here and do user or not. Oh, you know what? I don't have 3 users. Demo fail.
Talk amongst yourselves, please.
Yes. Okay, clients work. So that's a thing. Again, we're returning the client back, right? We can continually do this. But the fun part is if I just was an ass, I could just run exit, and I just killed the server, right? So that's pretty bad, So let me start that back up. So how do we fix that? One thing is to whitelist, like we've been talking about. Let's not exit again. One thing is to whitelist this, and if we look at the, oops, wrong window. Bear with me here. One thing is to whitelist, right? We have the same kind of thing. But really, just to try to avoid using eval altogether. Alternatively, you can use something.
Don't use it with user supplied parameters.
Yes, you can use something like send, and then the whitelist and the validation things we were talking about before. If you do have to, like with something like a training website or something like that, or if you are intentionally bringing in that code from the user, then try to sandbox that in some way, either with Docker, a custom interpreter, a separate page, something that you would spin up in an instance every time the user opens that particular resource. That way, if they do send something horrible to it, there's nothing sensitive in there, it's sandboxed or isolated from your original environment. We have a really ghetto demo of that we're going to get into, but we'll
It's
see.
not
how
ghetto,
that
it's nice.
goes. Oh, it's the, actually you should probably just put it straight to production. So, but honestly, try to avoid it altogether. So first, I'll show you the whitelist fix, which I'm pretty sure I'm on the right branch, right? Yeah. So again, now if I put client in here, I'm still getting the employee, right? Because I'm defaulting to that employee object. So no matter what, I'll always get employees no matter what goes in there. And for the sandboxing example, we will try to get this into Docker eventually if we continue to support this demo app.
The idea would be you run the unsafe code in like a Docker container. Docker itself isn't really a security sandbox, but it's something you can throw away if someone destroys it or they rm-rf or exit, whatever. You don't really care as much.
Yeah, so for something like this, the idea would be that when the user is coming in to put in their commands, that a new instance of this container would pop up. You would have the connections made back and forth between your application and that sandbox container. That way, if something happens to it or whenever they leave that resource, that instance is shut down, and then you continually spin up an individual resource for every user, every set of users, or whatever you might be. But just to show you that this is actually running commands, basically, if the backtick is kind of a system command in Ruby, but if I submit this, you see it's got my information here.
Yeah. So what that did was it went from a Rails app, used JavaScript to post to a Sinatra app, which actually evals the code, and then it sends the results back in an iframe, basically.
So that's the code for that. And the good thing about that is that if I do end up putting in something like exit, which it will eval because it's just taking in straight Ruby, it'll kill that container, but the application is still live and going. All your private information is isolated from that. So you would want to do something similar to that to try to mitigate that eval in that special edge case. But again, the recommendation will continue to be just try not to use it.
Don't be an idiot.
Yeah. So if this question was on my mind when I was kind of doing this, and if you were in the DevOps talk, they were talking about advanced search. So I did some searches on some of the things that we were looking at in the assessments. All I did was look in Ruby application controllers, only that path, and I looked for just eval params. So just straight eval from a user parameter, and there's 422 code results in there. Now some of this might be, demo code, people that are like, I just want to try Ruby. But that's kind of our point, right? Is that because there's so many developers coming into Ruby and because we want to teach and teach and teach, they may be making these mistakes, these simple things that we think are just common sense. But we want to kind of expose that and show another way to go about doing it.
And you can guess that Stack Overflow has a million of these examples of how do I run dynamic Ruby code? Use eval.
Right, exactly. For send, it was 877 results, and for the constantize example, again, just in controllers, it was almost 8,000. So it does exist on these open source repos, and that's excluding, the assessments that we've seen this in. And these exact examples, are being used. So I don't know if there is something on Stack Overflow that just, the way to do it, but obviously it's rampant and it's something we should probably address. So we're not poo-pooing on Ruby. We love Ruby. We just feel like there's a huge importance of implementation in Ruby because it is such a powerful language, because it allows you to rewrite so many things, so many methods, and it really opens the door to you to do a lot of whatever you want. The gems and the way people are using Ruby are continuously more inventive and cooler than you'll ever see, but you really always have to think about how an attacker might look at this application and how we look at these applications, so that when you are spinning up these apps, you kind of have that in the back of your mind all the time. And that is pretty much it. I think we're right at our 30 here, and have time for questions.
You can now speak. I know you guys are all holding back, so
Yeah.
this is now the time. And the code is up there. Oh my God, that's small.
Here,
There's
but, you know.
there's a link right there for the code, since that Rails app that we just showed is open source. And we also did a bunch of research into other open source projects that use Rails, and just searched through there to look for these kind of issues. So common gems like Spree and some other ones, we have the code up there, and we have the Brakeman results up there. You can look at those and kind of see that a lot of big name Rails apps and open source Ruby software uses these techniques in a kind of a scary way. So
this includes some of your recommended fixes, right?
Yes. So the way that the code is set up is there's 3 branches aside from master. Huh? Yeah, for sure. Troll.
What is a Ruby?
it's like Perl, but better.
It's red
Well,
and shiny. Yeah, so I have, that's impossible to see, I'm sorry. But yeah, there's 3 branches. One is Dockered, and that is the one that's kind of using the eval sandbox example. And the sandbox exists on Sinatra in a separate folder. So there's also some code examples from stuff we pulled out of GitHub inside of these folders here. So there's, if you want to look through these, they're publicly available in that search, and they're also here, and I've kind of labeled them as well. But yeah, so you just check out whatever branch you want to mess with. You want to mess with the weak branch, then go, and then switch over to fixes, and it should just change the demos controller to apply the fix.
And if you're a Rails developer and wants to check for these kind of things, definitely run Brakeman, because Brakeman has some pretty good tests for send and constantize and eval, things like that. So
Yeah, we run Brakeman for all of our platforms.
Yeah.
We have like an application on board, but to your point of, we have some new people come on board
Yeah.
for our Rails department, that we're trying to constantly have to reteach.
Yeah.
Don't use eval, what we send.
Right.
So being able to do something like this, that's kind of like the onboarding. This is how you want to do it. I think that's value there.
Yeah, that's great. That'd be awesome. Feel free to use it, because that's the ultimate goal, right? Is to, I mean, we don't want to, yell at anybody. We just want to say, hey, it's a different way to do it, and look at some alternatives.
I'm a big fan of Docker, so I'm probably going to get this set up as Docker container so that you can rm-rf to your heart's content and not blow away your.
That was the real example we
actual
wanted to
dev
use,
machine.
but I was too scared.
Yeah.
And he wouldn't do it.
I was
again.
confident that it would be fine, but he didn't want to blow away his box the day before our talk. So.
Could you use something like a static code analysis, like SonarTube or something to, and I don't know if it's available for Ruby, or you can run it to where your software code is to kind of make sure it doesn't have eval and other things like that.
I don't know about Sonar, but I mean, Brakeman's an open source tool Brakeman's an open source static analysis tool. Yeah,
and Brakeman is great for this kind of thing.
Yeah. But grep can find these issues for you, so grep is still the best static analysis tool.
Yeah.
So,
So,
So I can see why you guys love Ruby. It's just an opportunity.
that sounded like sarcasm.
yeah.
Not sure I like your tone.
I feel something coming.
No, my question is about, given the fact that there are so many kind of newbies coming to Ruby Rails, is there any formal effort to make run-of-the-mill developers and that got aware of all this? Because we were at a LASCON, so isn't there like a Ruby security guide?
There is one. I'm not sure how many people read it. I mean, there's a lot of stuff in the Ruby security guide that covers a lot of really good content. It's a little out of date, doesn't get updated as much as some of the other guides. I think there's so many like Code Academy, there's a site just for Ruby, RubyMonk, which kind of covers a lot of this stuff. They kind of glaze over security. They'll give it like a sentence like, this could be dangerous, but they don't show you why or how to do it the right way. So it's still like, there's still very much an attitude of just kind of use what's there and kind of ignore the security perspective of it. So
The other thing is, with metaprogramming as a technique, I mean, it's provided with the intention to make it easier and to provide you with a powerful function. It's just that you really have to look at the logic that you're implementing. And so it's hard to put that into a book. I mean, I have a metaprogramming for Ruby book in my bag that has an example that's probably vulnerable, but is that your own local app? Is that a public web application? It's all kind of in context. And Rails Goat obviously has some of the fixes in there, this
Yeah.
guy and that guy.
Yeah. So no like perfect solutions. Basically, it's still developer education and doing talks like this.
Like a minimum amount of knowledge somebody needs if they're new. Suddenly, at some point, they may realize and have understanding like, oh, these are real security issues that were like, when you're early on, you might not know, you might not have that understanding. Dangerous.
Yeah,
I mean,
exactly.
I don't think it's even just junior developers. I'm not trying to, shit on developers or anything, but there have been some people who've been like, why is this an issue? Why would someone pass in RM-RF? It's the same thing. It's still just about education and us talking to developers.
Do you
So.
go to Ruby Dev conferences or Ruby?
Yeah, we just spoke at a conference up in DC called Ruby Nation where we talked about Rails Goat, and that's really the whole point of that project is for developer education. So that's a no-loss project if you guys didn't know about it.
Yeah, man.
I can I just make a statement first? Like, I actually blame organizations over the developers in that, like, they need to learn this thing, like, having a good practice within the organization is important as far as making sure they're learning and like pairing or, and doing pull requests and that sort of thing. Like, so when you do assessments and serious sort of thing, like, what do you say to people as far as like, hey, this is what you need to do moving forward? Like, it's one thing to say, hey, fix this bug, fix that bug, but how do you actually coach them on like, hey, this is how you probably need to change how you're working so that, this stuff's getting distilled down to the juniors or that the seniors are able to like, proactively prevent this going forward.
Yeah, I mean, I think a lot of things we've encouraged people to do is use tools like Brakeman because it's hard to change the culture from the outside. I mean, you hand off someone an assessment report, they're not going to be like, we're going to change how we do everything, We try to really help them fix these issues one by one, and then make recommendations of how to use technology to kind of reinforce these things. Because if Brakeman's alerting you all the time, like, you're doing this wrong, you're doing this wrong, you're doing this wrong, it kind of beats into people's heads. But still, you have to have some people in the organization that care about security to make those changes. So, and those people have to come to conferences like this to learn about it and, educate themselves. So, but you're a developer, aren't you? So of course you wouldn't blame developers. I'm not blaming developers. Just to be clear.
Is that it?
Is it now time for the beatbox contest?
I'll let you go ahead and do that. Thank you.